Well, let's try this example. If we have a simple example, HCl plus NaOH gives us NaCl plus H2O. Now this is a very familiar equation. Hydrochloric acid, an acid, plus sodium hydroxide, which is a base, it gives us sodium chloride plus water. First step, we want to balance the equation. We have one H here, two H's. Here we have two H's, chloride, sodium, and we have sodium chloride. So it's balanced. And one oxygen, of course. So this is a balanced equation. If we were given, let's say an amount. So we have 5 grams of hydrochloric acid, and we have 4 grams of sodium hydroxide. How much sodium chloride will we get? Remember, one of those elements will be in excess and the other will be the limiting reactant. So we want to find out how many grams of sodium chloride. First step we do is here is the mass. And let's write here the molar mass. And here the moles. And I'd like to write them, my teacher taught me this way. It's really neat. So you write them this way from up to down, and I'm going to put a symbol dividing here and multiplication here. I'm going to explain it in a little bit. So let's calculate the molar mass. First of all, we want to find the grams here. We have to go through the moles. Everything, well, most everything, when it comes to this way of calculating the grams is, or actually calculating anything else, goes through moles. Okay, so hydrogen molar mass is 1.008, chlorine is 35.45, so that would be around 36.50. Sodium, I believe, is 22.9, plus oxygen, that's 16, so that's 38.9, plus hydrogen is 1, so it'd be 40.06 approximately. And let's calculate while we're at it the NaCl. Sodium is 22.9 and 35.45. That would be 35 and 22 is 57, so it'd be 58.35. So we have all the molar masses of the elements. The H2O doesn't matter at this point because we're really not calculating anything with the H2O, but it's 18.06. We want to have it just in case. Here we divide 5 divided by 36.5. That will give us C. This is where the division symbol comes in place. And that's what will help us right now. So let me calculate it. 5 divided by 36.5 approximately 0.13698 moles. I can keep going on and on and on. And what about 4 divided by 40.6 equals 0.09852 moles. So here we're clear, since the ratio is 1 to 1, then we're clear that the NaOH has less moles, because it's 0.09, less moles than the hydrochloric acid. Therefore, NaOH is the limiting reactant, and hydrochloric acid is in a little bit in excess. So since the ratio here is also 1, so 1 to 1 to 1, we're gonna put this here, 0.09852. And so as we can see, we calculated the moles of sodium chloride. Now, how do we get the grams? This is where the multiplication here comes in place. So here we find out that if we multiply 0.09852, which is the number of moles of NaCl, by the molar mass of NaCl, which is 58.35, we get 5.748, if I want to keep going, grams of NaCl. And so be careful, because one would think, oh, 5 grams of HCl plus 4 grams of NaOH would give us 9 grams of NaCl, but that's not the case. So it's 5.7.